right? Okay, thank you very much. It's a pleasure to be here. Thanks to Sandra for the very nice introduction and to the organizers for inviting me here. Because I don't know a good portion of you guys in the audience, I prepared what I call an elevator pitch. That tells you, like a minute, what I do in general. And I have another slides about other things I do that you will find on my webpage that are not included in this talk. So in general, like all things mobile, starting from building devices and making them efficient so that we can gather data about user behavior through sensing generally. And we do this efficiently, and then when the data comes out of these devices, it's often very fine-grained, both spatially and temporally, and that's why we have also looked at new models, new metrics, new techniques to analyze this data. And all this, as a computer scientist, then feeds back into, of course, better services and better systems, but also I've recently more and more use this to feed back into other disciplines. So I work with architects, urbanists, recently with clinicians and zoologists to use this knowledge back in their discipline. So I'm very pleased to be here with this crowd. This is like a snapshot of things that we have been doing that I will not talk about. We have tagged badgers to understand their behavior. We've tagged humans a bit like I think you heard a talk from Chiro yesterday about the device you're carrying, and we are understanding the technology that is best to do this sort of tagging. Recently, we're working on angle of interaction detection through devices. We built a bunch of applications, psychologists and health psychologists, to help the recording of mood through passive sensing, like the microphone for emotions, or with other passive sensing, and also recording of mood through questionnaires, as well as helping people to quit smoking with the understanding of their behavior through passive sensing. All these things I will not talk about today. What I will talk about today is our work related to platforms of geo-social interactions, and the biggest data set we work with for this is called Foursquare. How many of you are familiar with Foursquare? Can you raise your hand? So we have about half, I would say, of the audience. So Foursquare is nothing else but roughly Facebook, where you also tell your friends where you are. So I could check in this audience, in this location, and my friends would get to know that. All this data is then logged into a server in Foursquare, and you can also tweet about your check-in, so you can link platforms. So to give you an idea, a very minimal idea of how this data looks like spatially, I have a little animation. Before I run it, I want to tell you that the colors are the different categories of places that people have checked in. This is an animation that my collaborator, Anastasios Noulas, was running a tutorial on Monday, if you were there, as prepared. And the colors are different categories. The dimension of the circles is the size, so the quantity of check-ins in that place. And we'll see a temporal sliding of this, if I can find my mouse and go to animate this there. So from midnight on, we have activities coming out to different categories. Red is parks, blue is, so the light blue is travel, and we have, again, places of work in dark blue, food places in yellows. So the city is used at different times and by different people at different categories of places. And these places are somehow seen as a planar network where transitions of individual, I check in here and then I check in somewhere else, will give us a spatial graph, so the place network. And we also have a spatial network of people that know each other and decide to share data with each other. So there are two networks there. In the data set that we have used, there are about, let's consider London, there are about 500,000 check-ins for about 9 months, about 42,000 venues, and about 40,000 users connected here. So that's the kind of data we've been working with. And you can see this as a sort of two-layer interconnected networks where users visit places and places act as connector maybe for users. So one of the questions we have tried to answer is about the role of these places, their ability to connect a diverse set of users. There are questions related to the temporal profiles of places and how their business model, once they open, can be predicted. There are questions about how places connect to other places. There are lots of interesting questions, but initially I want to concentrate, especially for this talk, on just a couple of things that might interest this audience. So if you consider the definition of brokerage and structural holes as defined quite a long time ago by Bert, essentially it's a definition that in a network gives an idea of how important you are in your ego network for connecting other nodes that are not necessarily connected otherwise. So you can act as a bridge of information, you can broker information from one node to the other if these other two people are not connected. How much are you connecting a disconnected portion of your ego network is really what this measure is suggesting. And we were thinking that this measure might be good to bring to the kind of spatial network, to understand how places could have a brokerage value and what we could use this brokerage value for. Brokerage has often been connected to, so the fact that you have an open network is often connected to social economic prosperity in general. They've done studies in organizations showing that who has an open network is often doing very good performance-wise and salary-wise. So there is a link between network openness and prosperity. And we wanted to bring this theory to an analysis of places with the data we have. So can we find a definition that says that the ability of place to connect otherwise socially disconnected individuals can be studied and can lead to perhaps other studies. I think something is probably bumping here. I don't want this to bother you. Sorry for realizing late it was this. Is it better? Sorry, Sandra, I should have pointed this out. The other one okay? I think it's only on this side. Sorry. Okay, so place brokerage. Probably I imagine half of the audience will say, yeah, there's really, we know where you're going with this, but I hope the other half appreciates me being slow on this concept. So if you have our two-layer network, as I said, you have a place network where we have check-ins that temporally give us a sort of spatial graph of people flowing from one place to the next, and on top you have your social network of users connected because they are friends. Can we somehow define a place brokerage definition, which is really based on the existing definition and just says how many of the users in the social network that are not connected on the social network is this place making be together? In other words, how diverse is the audience in this place? Am I connecting people that are already connected on the social network, or am I connecting people that, am I, meaning I, the place, am I connecting people that are in fact not otherwise come into contact with each other because of their social links? So we looked at the sort of definition. The definition there is nothing more than the applied definition of Bert. So we have a sort of, I guess is there a pointer I can use instead of using? It's okay, I can go on and then find me a pointer. So the definition of a neighborhood of a node is down. I'm going to go here, if you can follow me. So at the denominator here, you have the definition of the neighborhood of a location L in the social network up there. So a neighborhood of L is these two nodes here. Or we also have an H which defines the, thank you. Is that? Great, perfect. You also can use the H to define an horizon, so you don't have to go only one hop in your social network, you could go multiple hops. And then on the denominator here, you have the edges that already exist in the neighborhood. Are these people friends already? We're counting these edges here. So I'm the place here. Am I connecting people that are already connected, or am I connecting people that are not connected, is what that formula. You can ask me the details later, or I'll give you a reference to the paper. And now, just to wake you up a bit, there is let's say a funny slide about some of the results. Remember, this data is quite noisy and quite large, and it has some sort of level of, I guess, error, but there is a signal. So this is a social brokerage. The more you go towards one, the more you are a broker in place, a place that connects people that are not connected otherwise. And there is a signal that says residence is different from travel, is different from art places. So there are places where you have more mixture, and there are places where you have less mixture. And then I see you already giggling. This is really for you to have fun. I will not stand by this and saying this is completely true, but you can see there is a signal there too. It's not strict science, but certainly football and art museum is more brokering, perhaps more diverse audience than a football place where people meet all the time, and maybe they're already friends, they're coaching the same people. Mall and laundry I also find interesting. There are a few others I find interesting. Now what? Okay, we've found the relationship between brokerage and places. We have differences, but couldn't we, as you can see here, we could have already kind of assumed this from the category name, and we just formalized it. Now we said that brokerage is related to, in other contexts, has been associated with social economic prosperity. So, one thing we have done, it will take me a while to explain this graph, is to look at an index of multiple deprivation in London. It's a sort of social economical index that the government collects through questionnaire, statistical analysis every 5 years on the population. And the higher this index for an area, the higher it is the value that this area is quite deprived. So we looked at the correlation between that index of multiple deprivation, which is on the y-axis here, and the brokerage rank of our data for the months of study we had, which happened to coincide with a few with the period in question of the questionnaire. So this is the brokerage value of the areas aggregated for all the places in the area. This is the rank of the places in 2011. Notice that the area of Hackney was the second most deprived at that time, but it was also one that had a very, according to the data, a very high brokerage value. Now, what we see here, that the darker color in the picture also indicate a change in the index of multiple deprivation in the 2016 collection. And what we see here, that there are a number of neighborhoods that had a high brokerage, so indicated high diversity in the environment, that have changed the deprivation index substantially. More information is contained in this paper that is also on my webpage if you're interested. Pietro Panzaraza is here in the audience, and you can talk to him as well, in addition to me, about this work. But essentially, there is a signal here that we have metrics that we can use on their social network that can be proxies for indexes that are more expensive to generate. And it might be that given that this network data is collected at a very fine granularity, then it is likely that we can do this sort of measuring and correction and helping a bit more frequently. So that's one of the main results. Clearly, this sort of analysis has applications. As a computer scientist, I also like to give this side of the story for searching, local searches. If you want to find places that bring together strangers or add cohesiveness to a group of friends, place where you can have serendipitous encounters, or maybe you want a real-time system that allows you to change and flexibly search for places with different characteristics. All these characteristics can be studied through these network properties, and we have a few other measures I'm not presenting in that paper that can be used for this purpose. Now, in the rest of my talk, I want to also give you an idea of this kind of analysis we can do on the structure of the network as temporally changing. So another data set we have, again on Foursquare, is a 3 years data set of 100, the most 100 popular cities in the data set. Again, each city number of check-ins varies, and for this data set we only have the spatial network. We don't have any social information about the users. We don't know who the users are, essentially. But we can track the growth of a city, and the study has been done on the London network. And again, this is one of the slides that I put in to wake you up. The number of places and where they are in 2011, I keep using my hands instead of using the pointer, so here's where technology could be useful. Why do I have to use a pointer? Why can't I just use my finger and point there? That's the next step. So here are the places in 2011. Here are the new places in the data we have between 2011 and 2014. And in this picture, I'm not sure you see here, there's a little bit of red, there's some red and darker, almost white here, not darker, lighter, almost white there, is the places that have, with respect to, let's say, how it should be in average, more or less places than they should for that period. So in other words, they've grown more than average and grown less than average in those particular areas. I don't know how many of you are familiar with London, but this is the period 2011-2014. Does anyone of you have an idea why we have this very hot spot there? The Olympics, correct. So that was clear in the data, and there are other aspects that come out in the data we studied related to Olympics. I don't want to dive too much into it. So more interestingly, and I was discussing one Sunday when I saw a place in Cambridge opening up, the fact that you have a new location, a new node in your graph opening up, how does that change the distribution of popularity of the places around? In particular, if you open a new burger place, how are the other burger places around the area going to be impacted by this? And we've studied this under many dimensions. In this particular case, this is again London. All the new burger places we saw open in an area that already had another burger place 500 meters away from it. The red column is the median. And if this value of impact is higher than 1, and we have a definition, but I'll give you a loose definition here. If it's higher than 1, it means that the number of check-ins with respect to the last month have decreased. So what you see there is that most of the places, when you have a new burger place opening up, will have a decreased number of check-ins. So there is competition for this kind of resource users, and it's not a cooperative scenario. Same for bookstores, by the way. Airport gates, as you would expect, have an airport gate. That means probably there is a management decision that they're using that area of the airport, so they open another gate or something. I know you're hungry for more of this, so there is a table showing mean and median of various places in London with the same concept opening up. And it looks like those are the most competitive places, so tapas, restaurant, grocery store, cosmetic shops are all suffering. I say suffering, but train stations are good things they're suffering. So if you have less traffic on a train station, maybe they've done a good thing. We can also measure that. Most cooperative places, there is one result which we found difficult to understand, so we dug deeper. While some of the other restaurants were in the most competitive side, here we have the Turkish restaurants are actually very cooperative. They help each other. And as I said, we dug a little deeper, and one of the reasons is here that places Turkish communities tend to really be very cohesive on where they locate themselves. So the fact that another Turkish place opens there means that the community is growing as well. We use the Jensen coefficient. I'm not going to explain this in the paper. To show that generally the Turkish places have a higher density in the way they are placed than other places with respect to a random placement of this. So there is a sort of correlation there. Now, the last thing I want to talk about is one thing we're looking at. I've not talked about time yet. I've very much kind of aggregated time, and we have this very fine-grained time information. One thing we're looking at now is, can we predict new venues' popularity just by perhaps knowing about the location, knowing about other venues? Can we make a prediction model that helps new venues to perhaps cater for goods or cater for staff that they want to employ there? So again, to keep you up in the last few minutes, this is a profile of a type of venue over a week, Monday to Sunday, so you see the peaks. Do you have an idea of what this type of venue can be? If I give you a profile. It's not a church. You need to shout because it's not a bar or restaurant. It's not a station. The stations would have, for what we're seeing, would have higher peaks in the morning, and the lunchtime wouldn't be this. And the restaurants probably would have a lower peak towards the evening. They would be shifted. I should have shown you the rest. Sorry? A gym? It's a gym. Well done. So yes, it's gym and fitness centers, and that's their profile. And I'm really going to stop in a minute. I'm saying that we're trying to do our best to use the features that we have in the network to predict the profiles of these places and to try to do it accurately and maybe correct it once we have initial check-ins of this type of data, then correct the prediction we had and have it even more accurately. And this can probably be done. So the last thing I have to do is to thank all the people who have done this kind of work, and I've really not touched the data for this work. It's them who did all the work. We have a collaborator from Foursquare, Mascolo as well. Peter Panzerazzo is in the audience. Anastasios Noulas and Daisy Ristova have prepared the tutorial that was given on Monday, and the others are all co-authors in the paper. If you want to read the papers, they're all on the webpage, and yes, so please free to read them and write to me if you want more. We are able to share a few data sets if you ask us, so please let me know. Thanks.